Integration, lecture number 2. We tried to finish the equation of curve in the first lecture, where I explained you that in the question you will be asked about equation of the curve, or you will be asked about area under the curve, or you will be asked about the volume. So we did cover equation of the curve with few questions in the first lecture. Now moving to the lecture number 2, where you need to understand that your area is basically under the line, or under the curve. So that means, for suppose if you have your x-axis and your y-axis, this can be in shape for both. If I say we have a curve or we have a straight line, in both cases, if we have been given limits, let's say upper value is 7 and lower value is 3. In this case, upper value is 8, lower value is 2. So what we can say is area under the curve for these values, for upper value 7, lower value of 3 can be taken out using the integration. Similarly, area under the line can be taken out using the limit upper value as 8 and lower value as 2. Your set standard or the formula to take out value is area is equal to integration, area is equal to integration, your upper value and your lower value. Your upper value and your lower value will be used when you integrate y. Will be used when you integrate y. So the first step is integrate your equation of y and then apply your limits, your upper value, then your lower value. So what will happen is that your area with upper value and the lower value y dot dx will be shifted to what? When integrated, you will have integration of y, and this will be used as upper limit and lower limit. And then what will happen is you will substitute your value a, and then you will substitute your value b in the same equation that was integrated and subtracted with each other. Let's say, for suppose, just for the example, your upper value is 4 and your lower value is 2, and your y equation is x dot dx, right? So what does it mean? That means that this x represents the equation of the curve. What we need to do is we will be integrating x. So this should be x square upon 2. When we integrate, it will be x square upon 2. We will not be writing plus c here, because when we use the integration limits, we will have plus c and minus c. So plus c minus c will be cancelled out, and obviously there is no substitution in the value of c as it is a constant. So what you're going to do is you're going to apply the limits here. One is 4, the other one is 2. So in the next step, what we do is 4 square upon 2, we substitute 4, minus 2 square upon 2. So that means your upper value and your lower value will be substituted with the modulus sign. What does modulus sign do? In case if the area is negative, your modulus sign will change the area to positive. So 4 square is 16. 16 divided by 2 becomes 8. 2 square is 4. 4 divided by 2 becomes 2. So this should be 6. Modulus 6. So this represents your area. So your area will be what? 2. So what is the way? Your way is that you will be integrating x, you will be integrating your y equation, which will be in the form of x. When you will be integrating your y equation, you will apply upper limit and then you will apply lower limit. The area here was 6 mod 2. Thank you. Okay. Here's another example of the question where we will be finding out the area of the shaded region. You need to understand that your upper limit is 4, your lower limit is 1. Your upper limit is 4, your lower limit is 1. This is your equation of the curve. The diagram shows the curve 3x to the power 1 upon 4. The shaded area region is bounded by the x-axis and the line x and 4. You need to understand that it is bounded by the x-axis 1 and 4 and by the curve. So if we need to integrate this, your y is 3x to the power 1 upon 4. So that means your integration sign will be integrating y is equal to 3x 1 upon 4 dot dx. The more important thing that you need to understand is that whenever we need to find the area, we will be integrating the equation of the curve. We'll be integrating the equation of the curve. That means the equation of the curve is represented by y, or sometimes you need to find, you will have equation of line, you can integrate that as well. But obviously that will be represented by y as well. So that means this is 3x to the power 1 upon 4. Your upper limit here is 4 and your lower limit is 1. So this should be 4 and 1. So if we just solve this thing down, this will be written as what? 1 upon 4 is the power. So if we add 1 upon 4 plus 1, if we add 1 in this, the LCM will be 4 and there should be 1 plus 4, which means the end result should be 5 upon 4. The end result should be 5 upon 4. Considering that this is 3x 5 upon 4, so we will have 5 upon 4 in the denominator as well. 5 upon 4 in the denominator as well. So that means we will not be writing C, but we will put down limit, that is 4 and 1. So 4 3 becomes 12 upon 5, and this is x 5 upon 4 with limit 4 and 1. So what we can do is 12 upon 5, your first limit is 4 to the power 5 upon 4 minus 12 upon 5. Your second limit is 1 to the power 5 upon 4. So what we're going to do is, to find the area, we will be solving this in the calculator, putting down the value 4 and putting down the value 1. So the area is 11.18, which can be written as 11.2. So this was one form of the question where you'll be asked to find out the area under the curve. Which means in question 24, you need to understand that your lower limit is 1 and upper limit is 4 with the equation of the curve, which is 2 under root x. So since it is bounded by x-axis 1 and 4, so the upper limit is 4 and the lower limit is 1. Your equation here is 2 under root x, and obviously we will be integrating this to find the area. So to find the area, what important is to have this under root change to half. Your upper limit is still 4 and lower limit is 1. So 1/2 plus 1 will be 1 plus 2 upon 2, which is 3 upon 2. So can we say 2x 3 upon 2 upon 3 upon 2, and the upper limit is 4, lower limit is 1. When we reciprocal this 3 upon 2, this should turn to 4 upon 3, x 3 upon 2, and upper limit is 4, lower limit is 1. So when we just solve this thing down, 4, upper limit 4 is applied, 3 upon 2, 3 minus 4, 1, 3 upon 2 upon 3. So this entire thing will be in modulus. So the end result, the answer for this 9.33. So this will be the area for the question that was tested in November 2007, paper 1, question number 2. Okay. Now, sometime in the question, what you need to understand is the area will be given with this is x and y. If this is a curve and there is a line going, there is a curve and there will be a line going, and you will be asked to give the answer for the area between the curve and the line. So in this case, what you need to understand is that your lower limit for both and the upper limit for both will be same. Lower limit and the upper limit for both will be same. So what you can do is, you can always subtract to find the area of shaded region. Area of what? Shaded region. You can always have area of curve minus area under straight line. So one point is that area under curve minus area under straight line. So if the straight line equation is, for suppose, 2x plus 3 and the curve equation is x square plus 4. So the limits for both will be same. For limits for both will be same. So if we have limits for both that are same, and which is 2 and 4 and 2x plus 3. So what we need to do is, we will be solving the curve x square plus 4 and the line which is 2x plus 3. So to make it easy, area for the shaded region, you will have curve minus line. With limits, what are the limits? 4 and 2. So 4, 2, x square plus 4 minus 4, 2, 2x plus 3. This will give you your area of the shaded region, which means you will be solving, what? Finding down area under curve, which will be x cube upon 3 plus 4x 2 minus 2x square upon 2 plus 3x, and this will be 4 and 2 again. This will be 4 and 2 again. So we can substitute the values. 4 cube upon 3 plus 4 minus 2 cube upon 3 plus 4 2. So this will be the answer, minus 2 4 square plus 3 4. This is upon 2. Let's just cancel this down. And this should be what? 2 upon 2. 2 square plus 3 2. So what we understand here is that the answer of the curve, area under the curve, minus the answer of area under the line will be the answer for the shaded region in this particular question. So that means you need to understand that any area under the shaded region will be the area that can be subtracted through the two given equations as well. The other best possible solution is, what we can do is, we can see that the same question can be solved through area under curve minus area of figure, which is area of trapezium. So in this case, you will not have to integrate your straight line with limits. What you can directly do is, you can find out the area of under the curve, and then you can subtract what? The area of the trapezium. You can subtract area of the trapezium. So you will again have area of shaded region. You will again have area of the shaded region. Now that varies to question of what you are, what type of figure you can have. You can even have triangle, you can even have rectangle, you can even have square. So the figure will depend upon question to question. So you need to subtract the figure from the area of curve, or from the figure you need to subtract the area of the curve, or from the curve you need to subtract area of the figure. Both way around you can get the answer for particular shaded region. We will cover this more with examples in lecture number 3.